we will continue learning important SQL concepts, focusing on DCL and TCL commands. DCL stands for Data Control Language and is used to manage user access and permissions. The main commands are grant, which gives permissions, and revoke, which removes permissions. TCL stands for Transaction Control Language and is used to manage database transactions. Key commands include commit to save changes, rollback to undo changes, and savepoint to create checkpoints in a transaction. So remember, DCL controls access and TCL controls transactions in SQL. Let's understand SQL DCL commands, which stand for Data Control Language. DCL commands are used to manage user access and security in a database. The two main DCL commands are grant and revoke. First, let's look at grant. The grant command is used to give specific permissions to users on database objects, such as tables or views. For example, you may want a user to only read data but not modify it. The syntax looks like this: grant permission on object to user. Example, grant select on employees to John. This means John can view data from the employees table but cannot modify it. Now let's understand revoke. The revoke command is used to remove permissions that were previously granted to a user. The syntax is revoke permission on object from user. Example, revoke delete on products from Jane. This means Jane is no longer allowed to delete records from the products table. So, in summary, grant gives permissions and revoke removes permissions, helping maintain database security and controlled access. Let's understand SQL TCL commands, which stand for Transaction Control Language. TCL commands are used to manage database transactions and ensure data integrity. They control changes made by DML commands like insert, update, and delete. The three important TCL commands are commit, rollback, and savepoint. First, commit. The commit command permanently saves all changes made during the current transaction to the database. Once committed, the changes cannot be undone using rollback. Example syntax, commit. Next, rollback. The rollback command is used to undo changes made in the current transaction and restore the database to the last committed state. Example syntax, rollback, or rollback to savepoint name. Finally, savepoint. A savepoint creates a temporary checkpoint within a transaction. This allows you to roll back to a specific point without undoing the entire transaction. Example syntax, savepoint, savepoint name. So remember, commit saves changes, rollback undoes changes, and savepoint creates checkpoints within a transaction. We'll quickly understand some of the most commonly used SQL joins. Joins are used to combine data from two tables based on a related column, usually called a key. Let's go through each type step by step. 1. Inner join. First, we have the inner join. An inner join returns only the records that have matching values in both tables. So when table A and table B share the same key value, those rows are combined and returned. The SQL syntax looks like this. Select all from A, inner join B on A.key equals B.key. Think of it as the intersection between two datasets. Only the overlapping data is returned. 2. Left join. Next is the left join. A left join returns all records from the left table and only the matching records from the right table. If there is no match in the right table, SQL fills the result with null values. The query syntax is this. select all from A, left join B on A.key equals B.key. In simple terms, everything from table A is preserved and matching data from table B is added when available. 3. Left join with null check. Now let's look at a left join with a null check. This technique is used to find records that exist in the left table but do not exist in the right table. The SQL query looks like this. Select all from A, left join B on A.key equals B.key, where B.key is null. Here, we first perform a left join and then filter the results to keep only rows where the right table has no match. This is commonly used to identify missing or unmatched records. And that's it. We covered 3 important SQL join concepts. Inner join returns only matching records. Left join returns all records from the left table and matches from the right. Left join with null check returns records that exist in the left table but not in the right. Understanding these joins is essential for data analysis, reporting, and database queries. We'll cover right join with null check, full join, and full join with null check. Let's get started. First, we have the right join. A right join returns all records from the right table and only the matching records from the left table. If there is no matching value in the left table, SQL will return null values for those columns. Here is the SQL syntax. Select all from A, right join B on A.key equals B.key. In simple terms, every record from table B is included, and matching rows from table A are added when available. Next is right join with a null check. This is used when we want to find records that exist in the right table, but do not exist in the left table. The SQL query looks like this. Select all from A, right join B on A.key equals B.key, where A.key is null. After performing the right join, we filter the results to keep only rows where there is no match in the left table. This is very useful for finding unmatched records or missing relationships between tables. Full join. Now let's look at the full join, also known as full outer join. A full join returns all records from both tables. If there is a match between the tables, the rows are combined. If there is no match, the missing side will contain null values. The syntax is select all from A, full outer join B on A.key equals B.key. This join essentially returns everything from both tables, whether they match or not. Finally, we have full join with a null check. This query is used to find records that do not match in either table. The SQL query looks like this. Select all from A, full outer join B on A.key equals B.key, where A.key is null or B.key is null. Here, we first perform a full join and then filter the results to keep only rows where one side has null values. This helps identify unmatched records from both tables. To summarize, right join returns all records from the right table and matching records from the left table. Right join with null check finds records that exist only in the right table. Full join returns all records from both tables. Full join with null check identifies unmatched records from either table.